Hello, welcome to the course Excelling with Mathematical Modeling. Today we will be talking about an interesting model, namely the price and demand model. So, let me start with two equations, price and demand model. So, I have the price in this form and the demand in this form. So, I can say your Pn and Dn, they are the price and demand for a commodity at time n. Now, the very first term, so price at time n, and this is the price at time n plus 1. So, price at time n plus 1 is dependent on the price at time n plus the demand. So, as your demand increases, your price also increases. You have seen, say, during Diwali, your demand for firecrackers or the candles is huge, and at the same time it depends at what hour you are going to buy. The demand for the price for the particular candle or the firecrackers, they also increases. So, here's the more the demand, more the price. But at the same time, if there is more supply, then obviously the wholesalers has to reduce the prices. So, this is basically known as the supply function. So, first there is demand, there is a rise in price, but then there is a supply, an additional supply, and hence the person who is selling, they have to reduce the price so that their stocks are cleared. And this is a constant increase in the price. Now, when it comes to demand, this is the demand at time n, this is the demand at time n plus 1, and as the price increases, the demand falls and vice versa. So, it is inversely proportional. So, as you see that the price of a certain commodity which you want, but the price is quite beyond your reach or price is quite high, your demand becomes less. Okay, let's buy one of them, not 7 of them. So, that is why this demand is inversely proportional to the price. And then there is a constant decrease in the demand as your constant increase in the price. Here, your parameters, that is A1, B1, C1, K1, they are all positive. However, H1 can take any sign. So, now you have the idea of this demand and price model. Let us see the analysis of this. So, we start with the equilibrium solution. So, for the equilibrium solution, we have Pn plus 1 equal to Pn equal to P star and Dn plus 1 equal to Dn equal to D star, because there is no change from time n to time n plus 1. And you substitute these two here, and this is what you will get. So, if I quickly write the equations, this is Pn plus 1 equal to Pn plus A1 Dn minus B1 Pn square plus H1 and Dn plus 1 equal to Dn plus C1 by Pn minus K1. So, I will replace Pn plus 1 and Pn by some P star and Dn plus 1 and Dn by some D star. If I do that, I will get P star equal to P star plus A1 D star P star square plus H1, and D star equal to D star plus C1 by P star minus K1. So these two cancels, and from here we get C1 by P star equal to K1, and this implies P star equal to C1 by K1. I substitute this P star here, so I get D1 D star minus B1 P star square plus H1 equal to 0. This gives me A1 D star equal to B1 P star square minus H1 B1 C1 square by K1 square minus H1 B1 C1 square minus H1 K1 square divided by K1 square. So your D star, this will be divided by A1. So your P star D star is given by C1 by K1 and B1 C1 square minus H1 K1 square divided by A1 K1 square. So this is your equilibrium point. So once you get the equilibrium point, you now have to do stability analysis. So we quickly okay. So in the stability analysis, what we do is, so let me write the equations. So we take some function f1 equal to p plus a1d minus b1p square plus h1, and similarly the function f2 which is in dn plus 1 as d plus c1 by p minus k1. So your Jacobian matrix will be del f1 del p, del f1 del d, del f2 del p, and del f2 del d. And at the point p star d star. So if I do that, del p, so it is 1 minus 2 b1p. This is a1 del p minus c1 by p square, and this is 1. And this needs to be calculated at the point p star d star, where your p star is equal to c1 by k1 and your d star is equal to b1 c1 square minus h1 k1 square divided by a k1 square. Now as you can see here, it is only p star, so we substitute this value here and you will get 1 minus 2b1 c1 by k1 a1 minus c1 k1 square by c1 square, one of them cancels, and 1. So if I simplify, it is 1 minus 2 b1 c1 by k1, this is a1, this is minus k1 square by c1, and 1. Next we have to calculate the eigenvalues, and for that we find a minus lambda I equal to 0, where lambda is the eigenvalue, and your a 1 minus 2 b1 c1 by k1 minus lambda, this is a1 minus k1 square by c1, and this is 1 minus lambda. So this is equal to 0. And this you can write lambda minus 1, lambda minus 1 minus 2b1 c1 by k1 plus a1 k1 square by c1 equal to 0. If you simplify this, you will get lambda square minus 2 minus 2b1 c1 by k1 times lambda plus 1 minus 2b1 c1 by k1 plus a1 k1 square by c1. And then you have to solve for the lambdas, which will be lambda 1 and lambda 2. You take the modulus of them. If they are less than 1, we will say that the system is stable. Now let us look into this numerically. So we assign the values a1 equal to 2.5, b1 equal to 0.1, h1 equal to minus 1, c1 equal to 5, and k1 equal to 1. And if you put those values in A, which is 1 minus 2b1 c1 by k1, a1 minus k1 square by c1 and 1. If you plug these values, you will get them to be 0, 2.5, minus 0.2 and 1. And if you find the eigenvalues, this will be 0 minus lambda, 2.5 minus 0.2 and 1 minus lambda equal to 0. This will give you lambda into lambda minus 1 plus 0.5 equal to 0, lambda square minus lambda plus 0.5 equal to 0. If I solve this, lambda equal to minus b plus minus root over b square minus 4 into a into c divided by 2a. So 1 plus minus 2, so minus 1 divided by 2. So I can take half plus minus I half. So 0.5 plus minus 0.5i. So it's imaginary eigenvalues, and if you want to take the modulus of that, you get mod of 0.5 plus minus 0.5i, which is square root of 0.5 square plus 0.5 square. And if you simplify this, you will get 0.7071, which is less than 1. So the system is stable, namely a stable spiral or a stable focus. So your price and demand model gives you stable focus with this kind of parameter values. Now let us look into the numerical solutions and visualize the graph with the help of Microsoft Excel spreadsheet. So I already have the spreadsheet open. Now this is one small technique which I like you to show, that if you want to calculate eigenvalues with the help of Microsoft Excel, so this is what you have to do. So the very first thing is, I have taken an arbitrary matrix, that is 3, 2.501, and I can easily see that eigenvalue of this is 3 and 1. So I know the result of this eigenvalue. Then I write the identity matrix. Then I put the lambda and I put a minus lambda I, and then determinant a minus lambda I. So basically I need to solve determinant a minus lambda I equal to 0. So, for that first I calculate A minus lambda I, and to calculate this, what you do is you highlight this cell and put an equal to. Okay, before putting an equal to, you know that it will be A minus lambda I, so it will be a 2 cross 2 matrix. So, first highlight this 2 cross 2. So, what you do is you first highlight these 4 cells, because it is a 2 cross 2 matrix, and when you multiply A minus lambda I is going to give you a 2 cross 2 matrix. So, you highlight these 4 cells and put an equal to, and then select this A minus, put an arbitrary value of lambda which is 0, multiplied by this I. And then what you will do is you will press Control Shift and then enter, and only then these 4 values will simultaneously come. So, one more time, to calculate this A minus lambda I, as you can see, you have to highlight these 4 cells first, put an equal to, select this A minus lambda multiplied by this I, and then press Shift Control at the same time and then press enter. Then these 4 values will come. So, this is your A minus lambda I. Next, you calculate this determinant of A minus lambda I. So, which is equal to, now for determinant, the formula is you type MDET. So, this comes matrix determinant this gives the matrix determinant. So, MDTERM. So, you click this. So, this gives a matrix determinant of this value, A minus lambda I. You close it and enter. So, the reason I chose this matrix, so you can check the result at each step. So, determinant of A minus lambda is this, and if you know this determinant, you expand this is 3. So, this value came to be 3. So, now you know it. Now, the final step is that you go to this data, then go to this what if analysis and click goal seek. Okay. So, what is your goal? The goal is that this determinant A minus lambda I will be equal to 0. So, I click this cell. So, this cell value is 3, 2 value 0, and how will you do that? By adjusting the values of lambda. So, you click this and click OK. So, you can see that one of the value it gave lambda to be 1. Now, here is the problem. The problem is, I can see that values is 3 and 1. So, it will give a value 1 at a time, and you have to be a bit close to the actual eigenvalue. So, that is one deficiency of this particular thing. But at least once you get the one value, you can easily calculate the other one with the help of hand, or otherwise you try, you have to just guess the initial value. So, here if I now put the value to be say 2.5, because I know that the value is 3. So, again I will go to if analysis, goal seek, then I again choose this determinant, this value has to be 0 by changing the cell lambda, and let me see, okay. So, now it comes to 3. So, this is a little of disadvantage, but some sort of it works quite well. So, if you play it with a little, with few iterations, you will get all the eigenvalues. So, this is a technique how you can calculate eigenvalues using Microsoft Excel. Now, let us look into the formula. So, quickly I write it here. It was like Pn plus 1 equal to Pn plus A1 Dn minus B1 Pn square and plus h1. And the second formula is dn plus 1 equal to dn plus c1 by Pn minus k1. This. And the values of ai's, so a1, b1, h1, c1 and k1. So a1 is 2.5, b1 is 0.1, h1 is -1, c1 is 5 and k1 is 1. Let me make them a bit bigger. Okay, so here is my n plus 1 and here is my dn plus 1. Here I put n. So start with 0 and this is equal to 0 plus 1 and drag it, say 30-40 values. Okay. Say up to 50 values. So this is the initial value. Let's take as 4 and 2. So this is equal to Pn, which is this value, plus a1, which is 2.5 times dn, which is this value, minus b1, which is 0.1 times Pn square, so this square, plus h1, which is -1. So -1. And this is equal to dn, which is this value, plus c1, which is 5, divided by Pn, which is this. Let us put this in a bracket, minus k1, which is 1. Now let's drag this value up to 50. Okay. So if I now plot this, you go to insert, I go to this chart and I plot this. So I can write price model. The series, I go to select data, series 1, edit, I just write price, and series 2, edit, I just write demand. So you get this curve, and sometimes if you want to copy this curve, so right click, copy, go to your slides and paste. So in this particular case, I have to close this graph. Well, let's keep it like this. Okay, so what you just see that we have numerically drawn the figure of this model which we were describing, the price and the demand model, which is this. And what you see that initially there is an increase of price, an increase of demand, and ultimately both price and demand, they come to a steady value, the steady value being 5 and 1.4. So with this we come to an end of this interesting model of price and demand model. And what you can do is, in this particular model you can change the values of the parameters and to see that how this curve behaves by changing the parameters of A1, B1, C1, H1 and K1. In my next lecture, we will be talking about two discrete models, namely paper tower model and calorie burning model. Till then, bye bye.